for example 14, the final example of this lesson. It's about time. Let D of t be the U.S. national debt measured in billions of dollars at time t measured in years. The table gives approximate values of this function at selected times by providing year-in estimates. Speaking of estimates, estimate the value of d prime of 2012 and indicate units of measure. So here's another application of a rate of change in the form of a derivative. Now, unlike some of the other ones, in fact, all the other ones, our function is just denoted with a table of values. So it's not like we have anything to perform the limit definition of. So how am I supposed to estimate this derivative if I don't have a function? Well, we do have a function. It's just a table of values. And this is the only information that we have for that particular function. So this is what I want you to think about, of course. So where did we get the tangent line to begin with? We had the tangent line. Let's say if I have myself some sort of graph, whatever this thing is, and let's draw maybe a purple graph. If I want the tangent line at a particular point, let's pick any particular point there, draw in the tangent line. Look how perfect that was. Remember, it's without calculus, it's an impossible thing to get. So why did I choose purple again? So what we have to do is we have to choose a second line, a second point here, and actually find the slope of a secant line. And if my 2 points are close enough together, and these definitely are not, if my points are close enough together, then I'm going to get as close as possible to the slope of that tangent line. And that's what I have to do for this particular example. Since I don't even have 2012 in the data, I have to find the closest secant line to 2012. So what data points should I use? How about one above and one below, like this? Boop, zip, zip. I have 2010. I have 2015. So if I find the slope of the secant line in between those, I'm using that slope to specifically approximate the slope of the tangent line at 2012, which is what the question is asking me about the derivative of 2012. So that's all I got to do. And is this a realistic thing that the calculus exam would expect us to do? Absolutely would be, right? So it's going to look like this, d prime of 2012. And make sure you don't put equal signs because it's not equal to. I'm not finding the actual derivative. It's just an estimate of the derivative. So I'm going to use the approximately equal to symbols, the little wavy lines. All right. And I just do my regular slope, change in y over change in x. Just keep it in the same order. I've got 21,700.0 minus 14,025.2. All of this over, in the same order, 2015 minus 2010. Let's throw that in the calculator. Unless you want to do that arithmetic in your head, you're free to, of course. I'm not gonna. I'll pull up Desmos. And I don't remember the numbers either, so I'm also going to pull this slide back up too. Okay, we have, hey, I'm going to hit this fraction button. That's very handy. 21,700 minus 15, no, it's 14,000. 14,000, 025.2, all over, and I think I can do this part in my head, just over 5. Okay, so we have 1,534, 1,534.96. All right, there's our derivative, the value of our derivative. Let's throw some units on this thing, and let's try to attach some sort of meaning to the mathematics that we just came up with. Okay, so look right here at what we calculated, a change in y over a change in x. Our y values that are on the top, they're in billions of dollars. That's what's going to go up top. So billions of dollars. And on the bottom, these were years, right? I can see that right there, years. And so the rate here, or the indicated units of measure should be billions of dollars per year. And it's supposed to be at that particular year, at that particular instant. And it's just an estimate of it. So I'm going to say something like this. At 2012, there's a speedometer on this debt rate. And when I say speedometer, it's also, it's more like a velocity because it has a sign with it, right? It has a direction. All right. And in this one, it's increasing. It's a positive number. Specifically at 2012, the U.S. national debt was increasing at a rate of approximately, I'm throwing that word in there because we used actually a secant line to approximate this, is increasing at a rate of approximately $1,534.96 billion per day, per minute, per second, per year. And for that, and for my part of that, I absolutely apologize, right? I'm sure my generation has contributed quite a bit to that national debt, and it's going to be your problem to deal with. All right, well, that brings us to the conclusion of this lesson here on derivatives and rates of change.